Hi everyone. Today I brought some wonderful questions from the chapter of Newton's law, and we will be doing problems involving friction where blocks will be kept on top of each other and we have to find acceleration for the blocks in different cases. But before I start that, I want to just revise quickly how to use Newton's second law, how to draw the forces, okay? And if you know all these basic things, you can directly go to the part where I start the problem solutions. Okay, so basically Newton's second law says if you have a system, okay, a system can be any body or a collection of body, and the acceleration of every part of the system is a, let's assume. So all the parts are moving with same acceleration. If different parts are moving with different acceleration, then we have to apply center of mass concept, which we will study later. So we will assume in this system all the parts are moving together with same acceleration a. Then it says the total external force on this system is equals to m into a. So where m is the mass of the system, and this F represents all the external forces on the system, not by the system, on the system. Okay. So these are the steps to apply Newton's second law. First thing is choose the system. That's the most important part. Okay. Choose the system whose acceleration you want. Okay. Then draw all the forces acting on the system. Again, on the system, not by the system. Then if the forces are in different direction in a plane, then take components of the forces along x-axis and y-axis. After that, use Newton's second law separately for x-axis and y-axis. Now sometimes the acceleration along x-axis may be 0. Then from Newton's law, net force, total force, this represents summation symbol. Okay, so the total force along x should be 0. That simply means if one force here is 5 Newton on the body and you know acceleration is 0 along x-axis, then there must be another force here 5 Newton in the opposite direction. Then only the total force will be 0 along x-axis. Similarly, sometimes along y-axis the total force may be 0 because there is no acceleration along y-axis. In that case, if there is an upward force of 10 Newton and downward force of 3 Newton, then you must know that there is another force downward 7 Newton. Then only the total of 7 and 3 can balance the upward 10 Newton. Okay. Now in the second step, we have to draw all the forces acting on the system, right? So what are the common forces that can act on a system in mechanics? Now the most common force is the gravitational force. Now what is gravitational force? Imagine this is an object of mass m and here is your earth. Now center of earth is very far, okay? So the distance between the body and the center of the earth, this distance is very far, okay? So this distance is, let's say, r, small r, and this is up to going to center of the earth. Then the force on this body by earth is given by Newton's law of gravitation, which is G m1 m2. m1 m2 means mass of one body, which is small m, and here mass of other body I am writing as capital M, divided by distance between the body and the center of the earth, which is r square. So this is Newton's law of gravitation. Now if this height is h and the radius of earth is capital R, then this small r will be what? Radius of the earth plus h. So small r will be radius of the earth plus h. Now in mechanics, at least when we start problem solving in mechanics, the height considered will be quite small. So these bodies will be at small heights compared to radius of earth. So this height will be very small compared to radius of earth. So we can neglect that. If you do that, then you will get here simply r square. Now capital G, which is gravitational constant, mass of earth and radius of earth, these guys are constants. If you substitute their values, you will get 9.8 meter per second square. And this is what we write as G, and approximately we can take it as 10. So the force of gravity between earth and this body is small m, which is mass of the smaller object, into small g. and we call small g acceleration due to gravity of earth. Remember, earth you have to mention because this small g has information about what? Mass of earth and radius of earth. Now this is force between two things. Remember, force is always between two things, on something, by something. Force cannot act only on one object. Okay, so force is always between two things. Now where is the direction of this force? Now for that many students will say, sir, it's easy, direction of gravity is down. But that is not a very proper way to think. Whenever you want to show the direction of force, first remember what I told. You have to first choose the system. So if you say this object is your system, then you have to say the gravitational force is downwards because it is attractive force. But if I would ask you, show this force on earth, because on earth also there will be force by this body. Forces always comes in pairs. Remember it, okay? Forces always comes in pair according to Newton's third law. So if I push you, I will also feel a force from you. So if earth is pulling the body down, body is pulling earth up. Of course, because of earth's huge mass, earth will not accelerate due to this force. So when you drop a chalk, earth will not go up, chalk will come down because chalk's mass is less. So therefore acceleration will be more. So that is something you need to remember, because acceleration is what? Force by mass, right? Mass of the object which is accelerating. So though force is same for both object and earth, object's mass is less, so acceleration of object is more. But mass of earth is huge, so acceleration of earth is negligible in this problem when you consider earth and block system. Of course, if you consider earth and sun system, then their earth will become like the block and sun will say, hey, now I am the boss, I have more mass. So now you revolve around me, not me around you. So in that case, earth will accelerate around sun. Now normal force is what? Imagine there is a object which is on a floor. If the mass of the object is m, just now we learned there is a gravitational force mg downwards. Now because of that, it will push the floor down. So the floor will feel a push downwards. And therefore, floor will also push it upwards. Right? This pushing force, I am trying to make the length same because from Newton's third law, those two forces should be equal in magnitude. So this is the pushing on the floor. This is on the floor by block. Remember, forces comes in pair. And this is on the block by the floor. And this is what is called as normal force, N. Okay, it is a pushing force. Now, of course, you will not show both the normal force on the same body, right? If I push you, reaction will be on me, action will be on you. One of them you can take action, other one will be reaction. So block is pushing the table down. So this is force on table or floor by the block. Reaction will act on the block by the floor. So if you choose floor as system, then you have to draw this force. But we never choose a floor as system. We will choose this block as system. So then you don't need to show this force. Okay. But in case somebody says, no, I want to choose floor as system, then you have to show force on the floor by the block. Clear? Now, these two forces are acting on the block, right? This is on block by floor. This is gravity. So this is on block by Earth's gravity, isn't it? Isn't it? So these are both forces on the block. Such a diagram where you draw forces on a system. First, you have to choose the system. That diagram is called free body diagram. Okay. And now you know if this block is at rest, let's say, then you know there is no acceleration along y-axis. So normal force should balance mg. Okay. Now sometimes you may have two block system like this. M1, M2. Okay. So now if somebody will ask you what is normal force here between M1 and M2, don't show up or down without thinking who is the system. So if you choose M1 as system, then you know M1 is pushing M2 down. So M2 will push M1 up. So normal force here on M1 will be up. This is on 1 by 2. Okay, normal force here. Let me write N only. And that will balance gravitational force of M1, which is M1G, because the system is at rest. So here N will be simply M1G here. Similarly, if I want normal force here, then take both of them as system. If you take both of them as system, then whatever force X here, and that will cancel, because M1 may feel force upward because of M2, but M2 will feel force downward because of M1. So internal forces will always cancel, so we don't need to show, only external. Now floor is external, right? If you choose this as system, so floor is pushing up M2 with some normal force, and gravity is pulling the system down with what force now? M1 plus M2 G. So here normal force, if I say N dash, it has to balance not only the weight of M2 but also M1. Okay, so this you should be able to do very fast. So if they give you multiple block system like this, here normal force will be how much? If they ask here, it will be weight of this. Normal force here, weight of this. Because normal force here has to balance the weight of this, and normal force here means weight of this. Of course, I'm assuming the whole system is at rest along y-axis, so no acceleration along y-axis. Then only you can balance the forces. Now imagine there is a wall where I am applying a push. If I ask you to draw normal force, don't start drawing. First ask who is the system. So if wall is the system, you have to show normal force here. Okay, this is normal force on wall by hand. And if you choose hand as system, then you have to show normal force here. Remember, action reaction pair are always equal and opposite. Now what about tension force? Okay, so imagine there is a rope or some string or wire which is tied to a wall and it is connected to a block. Now I am pulling the block this side. This is my pull. Now I want you to show me where is the tension force. Again, be very careful. When someone says draw a force, first thing you have to ask is who is the system. Before that, don't draw. It will be a trick question. So let's say I take this string as a system. This string. This is point A. This is point B. Now B point of the string is in contact with block, and wherever there is contact, there will be a contact force. So when I pull the block this way, the block will in turn pull the string this side, isn't it? So this is the pulling by the block on the string. So this is by block on string, or we can say on string by block. Now for every action there is a reaction, right? So string will pull the block this side, right? For this action, this is the reaction. So this is on string by block, this is on block by string, and this pulling force is what is called tension force. So tension is a pulling force. Again, which one is tension? Both are tension force. At one point tension will be same, but this is on the block by the string. So if you choose block as system, you have to draw this diagram, and if you choose string as system, then you have to draw this diagram. Now because of this pull, will the string go that side? No, the wall will be pulling it this side, right? So when string is pulling the wall here, when string is pulling the wall here, so this is tension T dash, let me say. So this is on wall by string. Then there will be a reaction of that on string by wall. Okay, so keep things simple, don't get confused. Now let's come to friction. Now imagine there are two blocks in contact with each other. Okay, and I am trying to move this block this side. Now if my pull is very small, you may see it is not going to accelerate. Okay, keep a book on top of another book and like this you do. Will it accelerate? No. If the book is quite heavy, then who is cancelling your pull, your force? It cannot be gravity or normal because those forces are along y-axis. They cannot balance this force. So it has to be force from this body because the only body in contact with this body is this body. So if I call this first body and second body, and you are pulling the first body and it is not accelerating, some force must act in opposite direction. That has to be parallel to the surface. And it is a contact force because it is due to contact between 1 and 2. That force is called static friction. Static. This is on 1 by 2. Why static? Because this one is at rest with respect to 2. Okay. Reaction of that friction will act on to, isn't it? Because for every action there should be an equal and opposite reaction. So this is on 2 by 1. Clear? So try to remember how to find direction of friction. One method is assume there is no friction. Assume there is no friction first. Then check where the body will move relative to the other body, or where one surface will move relative to the other surface. So for example, if I go back to this question again, so when I pull this, suppose you want to find direction of friction on 1 by 2. So on the surface of 1 by the surface of 2. Then what you do, sit in 2 and see where will you see 1 moving if there was no friction. So if there was no friction, obviously due to this pull, you will see 1 going that side. So friction on 1 will be opposite to that. So friction will act opposite to relative motion. So friction will act opposite to relative motion. So imagine this is block 1 and this is block 2. Before I applied pull on block 1, let me say I apply pull on block 2. I want friction on 1. First decide the system. So I have chosen the system as 1. So I want friction on 1 by 2. Where it will be? First thing, there was no friction. So completely smooth. So when you pull this block like this, in ground frame from outside you will see 2 going here. 1 will be staying there only because there is no friction to pull 1. Isn't it? So only 2 will slip like this. But I told it should be relative motion, right? Friction acts opposite to relative motion. So first, if you want friction on 1, what you do? Stand in 2 and now think as you move with block 2 this way. Where will you see block 1 moving? You will see block 1 moving this way, right? So friction will be opposite to relative motion. And reaction of that friction will act on block 2 this way. So this is how we can find, but the easier way is this, okay? If block number 2 is getting pulled here, then due to friction, block number 2 says, you also come with me to block number 1. So block number 1 should feel friction here, and reaction of that will be here on block number 2, right? So something like that you can remember. Or here, for example, when block number 1 was going this side because of the pull, it will say to block number 2, you also come with me, we have some friction, some bonding. So block number 2 will feel friction here from block number 1, reaction will act on block number 1 this way. So that way also you can find. Okay, now there are two kinds of friction, static friction and kinetic friction. At least for today's class we need these two friction. Now static friction comes in picture when two surfaces, this surface of the upper block and this surface of the lower block, when those two surfaces are either at rest or they move together. So if they are like this at rest or if they move together. Okay, because if they move together with same acceleration, then if you sit here, you will see this other one is at rest only, because initially we will assume they started from rest. So if both the blocks have same acceleration and initial velocity is 0, if initial velocity is 0 and you have same acceleration, then both the blocks will have same displacement in a given time. So after 2 seconds, both will cover same displacement. So one will see the other one is at rest, static. So don't think static friction acts only when they are at rest. It also acts when they are moving, but they have to move together. Understood? Now static friction doesn't have any unique formula. Static friction is self-adjusting, meaning the value of static friction is equal to the force needed to keep the two surfaces at rest with respect to each other. So one surface should see the other surface is at rest. So let's say one block is here and this is a fixed surface. Now you are applying 2 Newton, but this block is still at rest with respect to the fixed surface. Then what is the static friction value? It should be also 2 Newton. Then only this body will be at rest, right? So if you make it 3 Newton and still it is not moving, then static friction also should be 3 Newton. So it keeps adjusting depending on what is needed to keep this body at rest. Now let's say I have 2 block system and both of them are moving together with same acceleration. Okay, and let's say it happened because I am pulling the lower block. We will see more examples of this later, but I am just giving you an example right now. So because of my pulling, both of them are moving together. Now ask yourself, is there any force on upper block by the lower block? It has to be, because if there is acceleration, there has to be force. Now, because they move with same acceleration, if you sit in one of the frame or if you sit in one of the block, you will see the other block is at rest because they have same acceleration, right? So therefore the friction here will be static, and it is only the friction force that can give this acceleration to this block. So that friction force will be static. Okay, so please understand, though the blocks are moving, in this surface the friction is static. Of course in this surface, because this is floor, the floor is at rest only, but both are moving, so there is slipping. So when there is slipping, that friction here is kinetic friction. So here the friction will be kinetic when there is slipping between the two surfaces. But if the two surfaces move together, then it will be static. So this is on 1 by 2. Okay, and reaction of course will act, that we have seen, and we'll see more examples later. But just I wanted to give you the idea that don't think that the body should be always at rest for static friction. The bodies could be accelerating from ground frame, but with respect to each other, if they are at rest, which means they are moving together without slipping, they are moving together, then also the friction would be static. Okay. Now I told you that static friction is a self-adjusting force, right? It will be that much which is needed to keep the two surfaces at rest with respect to each other. They may move together, but they should have same acceleration, right? Now, is it compulsory that always they should have same acceleration? No, sometimes you can move faster than the floor, right? Like a train is moving, but inside the train you may move with another velocity. Why should you and train should have same velocity or same acceleration all the time, right? So whenever there is slipping between two bodies, then the friction is kinetic. That means if you keep applying force on a body at rest, one day it will 100% slip on the floor. That means static friction will try to adjust. However, it will have a max value. Beyond the maximum value, static friction will not be able to keep the surfaces at rest. So the maximum value of static friction has a formula given by mu s into n. N is the normal force between the surfaces in contact, and mu s depends on the nature of the surfaces in contact. It is called coefficient of static friction. So as long as your static friction is less than maximum static friction or equal to, we can say, till that point there is no slipping. No slipping means what? Either those two surfaces are at rest with respect to ground or they are moving with same acceleration. And once the body slips, then the friction acting is called kinetic friction. Value or formula is mu k into n. This is coefficient of static friction. This is coefficient of kinetic friction. Now sometimes they will just write mu. In those cases you have to assume the values are same. So if they give you only coefficient of friction, then assume both are same equal to mu. In that case, what will happen? The kinetic friction will be same as maximum static friction. Otherwise, mu s and mu k are slightly different. In fact, you should know that mu k is slightly less than mu s. So before we start the 3-block system, we would like to gradually go from 1-block system to 2-block system, then 3-block system. That will give you much clarity. Okay. So let's say I have a single block this time kept on a fixed surface and there is friction between the two surfaces. The friction coefficient is given 0.2. Remember, they have not given you mu s and mu k separately. Okay. They have just given you mu. That means this is the coefficient of friction, and since they have not distinguished between mu s and mu k, we have to assume this is both mu s and mu k. And if you do that, already we discussed Fs max, the maximum static friction, will be same as kinetic friction in this problem, because they have taken this mu to be both mu s also and mu k also. Okay. So this 2 kg block is resting on this surface right now, and then we apply a force of 5 Newton. We have to find the acceleration of the block. And one bonus question I can add, you have to also find the friction acting. So how will you do this problem? Now some students may think, sir, so easy question, force is 5 Newton, mass is 2 kg. So acceleration from Newton's law is force by mass, isn't it? F equal to ma. So A equals to F by m. Force is 5, mass is 2, answer is 2.5. Simple, sir. Finished. This is wrong, as I mentioned here. Why? Because there is friction also acting, right? And if friction is acting, we are not very sure whether this block will remain at rest with respect to the surface or the block will slip on the surface. Slip word here is very important, okay? So when the block will slide on the surface, I call it, or we call it, slipping. So in problems where friction is involved, in problems where there is friction, it is possible that the body may not move because of friction, right? You can try moving something in your house. If something heavy is there and you push it with your hand, it's not compulsory that object will move, right? So how do we find the acceleration of the block? So what we will do is, first, in such problems where there is friction, we will first calculate the maximum value of static friction at this surface. So what is the maximum value? Formula for that is mu s into normal. And you know the normal force from the surface will balance the weight of the body, right? The gravitational force. And the weight of the body is m into g. M is 2, so 2 into g I will take 10, so 20 Newton. So normal force should balance 20 Newton in this direction, because we know this block is not going to accelerate up or down. So total force in y-axis should be 0. So normal force should balance mg, which is 20 Newton. What is mu at this surface? 0.2. What is normal? 20. So this will be 0.2 into 20 will be 4 Newton. Right? So the first thing you have to do is calculate the maximum static friction. Now, when you apply this force, we know there will be friction this side, because this body wants to go on the surface this way. So friction between the surface and the block will try to oppose that relative motion, right? So block is trying to go here with respect to the surface. Block is trying to go here. Friction on the block will be opposite to that. Of course, reaction of that friction will act on the lower surface. This is the reaction of this, because forces always comes in pairs, remember. So for every action there should be reaction. But remember, this reaction is acting on the lower surface, which is not our system right now. So forget about this. Our system right now is this 2 kg block, right? So since there is friction, it is possible that this friction may be able to balance this, or it is possible this friction may not be able to balance this. So we don't know that, right? So first we will start with an assumption. And the assumption is the block remains at rest with respect to the surface below. Okay, so with respect to the surface below, the block remains at rest. If you stand on this surface, you should see this block is at rest. That means you should see acceleration of the block to be 0. And if acceleration is 0, net force should be 0. Net force 0 matlab this force should be balanced by this friction, and that has to be static friction, because we are assuming the block remains at rest. So what is the, if total force is 0, it means this 5 Newton this side and this friction this side, the total of that should be 0, means static friction should be exactly equal to 5 Newton, isn't it? To balance 5 Newton, how much should be static friction? 5 Newton, right? Now, compare the static friction with the maximum static friction. So this is called checking process. So here we have done the assumption. So first we assume the block remains at rest, because we don't know, before solving we don't know whether this block would move or not, even if force is applied, right? Even if force is applied, the block can still be at rest, right? Push your almirah at home with your one finger, try. The almirah may not move even if you are applying force. That is because some frictional force is balancing your force, is killing your force. Okay, so first we will assume, because we don't know, so we will assume that the block remains at rest. Now to keep the block at rest, somebody has to balance 5 Newton, and that somebody is static friction. So calculate the static friction by assuming this. Now check whether your assumption is correct or not. How to check? Whatever static friction you got 5 Newton, compare with maximum value. Is this more than maximum value or less than maximum value? This is coming more than Fs max. How can something be more than maximum value? How can your marks be more than 100? If 100 is the maximum marks, you can't get more than 100 marks, isn't it? So static friction cannot be 5 Newton because the maximum value itself is 4 Newton. So this is not possible. So our assumption is wrong. So since our assumption is wrong, acceleration is not 0. Okay. So since acceleration is not 0, now we are 100% sure the block is slipping on the surface. Slipping means it is sliding on the surface, right? So we came to know that our block here is actually accelerating with respect to the surface below. The surface below is at rest, remember. And forces acting here is 5 Newton. And here kinetic friction will be there. And in this problem, kinetic friction will be same as maximum static friction 4 Newton. Isn't it? So what will be Newton's law now? Total force will be how much? Net force equals to ma. What is the net force? 5 minus 4. Here 5, here 4. So total will be 5 minus 4 equal to mass is 2 into A. So A will be 1 by 2, which is 0.5 meter per second square. So this would be the answer of this question. So first answer is 0.5 meter per second square. And second, friction. What is the friction? Obviously the friction is 4 Newton. And what is the nature of the friction? Kinetic friction, right? Now, if the same problem had come like this, let's say this is 3 Newton, then what it would be? Well, if it is 3 Newton, then the friction required will be also 3 Newton to keep the body at rest. So you will do this assumption first, right? Then you will check. This time static friction should be 3 Newton. 3 Newton is less than maximum static friction, right? Static friction can go up to 4 Newton, up to. I am not saying the friction here is maximum value. No. Friction here could be either static or kinetic, depending on whether the body remains at rest or it is sliding on the surface, right? If it is sliding on the surface like this, friction is kinetic, and kinetic friction has a fixed formula, mu k into n. But here mu k and mu s are same. But if the block is at rest, as we have seen here, right? Because the friction required is 3 Newton and friction static value can go up to 4 Newton. So if you can get 100 marks up to 70 marks, though it is possible. So this is possible. So friction can be 3 Newton. And since this is possible, our assumption is correct. So acceleration will be now 0, meaning the block will be at rest because this friction will balance this applied force. So first answer will be 0, acceleration will be 0, friction will be how much? Don't say this, okay? This is the maximum value. Friction here is 3 Newton, right? Which is static in nature, okay? Now from one block problem, let us come to two block problem. So we have 2 kg and 3 kg block. Here the friction coefficient is 0.5 and here the friction coefficient is 0.1. We have applied here a force of 10 Newton. Now we have to find the acceleration of the blocks. Now before there were only two possibilities when there was only one block, right? Either the block will remain at rest or it will slip on the surface. If it is at rest on the surface, it will be static friction. If it is slipping, it will be kinetic friction. Correct? Now, in this problem, when we apply a force here, try to check where the direction of frictions will be. Because of this force, this object, 2 kg object, will try to slip this way. Will try to slip. It may not slip, remember, because there is friction here. It may not slip also. But it will try to move this way. So there will be friction this way on the upper kg block from the lower kg block, right? Actually it is on the surface, but for clarity I am showing slightly above. So this friction is on 2 kg by 3 kg. Now every action should have an equal and opposite reaction. So 2 kg block will exert friction on the 3 kg block this way. These two will be same in magnitude. So when the upper one moves, it will say the lower one, you also move. I am moving means you also move, right? Because they are in contact. my ear is in contact with my face. So when my face moves, it says my ear, you also come with me only, right? So there is bonding between the atoms of my ear and the atoms of the surface of my face here. So because of that bonding, when I move, my ear also moves with me. So when this 2 kg block moves this side, this will say the lower one, you also come with me. So this will exert force on lower one this side, and this will exert force on upper one this side. Because of this force on the 3 kg, 3 kg will now try to move this way on this surface. So this surface will say, "Arey, I am at rest. Why you are trying to move?" So lower surface will apply friction on the surface of this table or floor, will try to apply friction on upper block this way, because this is trying to go here, right? And the reaction of that will act on the table or on the floor, but this is not useful for us because we are not going to take the table or the floor as system. So these are the directions of friction. Now we don't know this friction right now is static or kinetic. That depends on whether these two blocks are moving together, or there is slipping, or they are actually at rest from ground frame. So now let me tell you what are the possibilities. Okay. So there is a possibility that all of them are at rest. So first possibility is all blocks are at rest with respect to ground. So when I see from here, or if I stand here and see, I see all of them is at rest. All of them. Then it means acceleration of each block is 0. Acceleration of each block is 0. This is the first thing that may happen. Now, what is the second possibility? The second possibility is when you apply force, the friction here is strong enough to keep both of them together. Like I told you, right? The bonding between the atoms of my ear and the atoms of this surface are strong enough, right? That's why when I go this way, this also comes with me. Together we move, right? So when this block moves this side, I hope you remember this friction is saying to this block, you also move this side. So if the friction is strong enough, it is possible for both of them to move together. If they move together, that is the second possibility. Blocks move together. By together, what do I mean? It means acceleration for both the block is 0. No, how 0? I am saying it is, they are moving, I am saying moving. But they are moving together, meaning they will have same acceleration. So acceleration of 2 kg block and acceleration of 3 kg block will be same. And if they have same acceleration, that means here there is, in the upper surface, there is no slipping. No slipping. Why no slipping? Because they are moving together. Sleeping matlab one will move faster than the other. No. Yes or no? Sleeping means one will move faster than the other. But if they move together, because if acceleration is same and both the blocks started with 0 initial velocity, both of them started from rest. So if acceleration is same and initial velocity is 0, then from kinematics you know displacement is ut plus half at squared. Right? So if A is same, displacement will be same because u is 0. So in same time, both the bodies will cover same displacement if acceleration is same. Okay. So second possibility is both the blocks move together, and if they move together, there is no slipping between the surfaces of the two blocks. And if there is no slipping, then the friction is static or kinetic. Some students think, oh, it is moving, so kinetic. Students, understand one thing. Moving doesn't mean friction is kinetic. If there is relative motion means if one surface will see the other surface is moving, like this. With respect to one surface, if other surface is moving, then there is kinetic friction. But if they move together, then if you stand on one surface, you will see the other surface is at rest. No, isn't it? If car is moving and you are inside the car, imagine you are the driver, and for you the steering, the car is at rest, no? So please understand, if two bodies move together, the friction between them is static because one surface will see the other surface is at rest. So just because you see moving, don't start thinking kinetic friction. Okay, kinetic friction comes when there is slipping, when one surface moves faster than the other. But if they are moving with same acceleration, then there will be no slipping between them, and no slipping means there will be static friction. So friction will be static in the upper surface. This is for the upper surface. But since they are moving on the lower surface there will be slipping. And since there is slipping here there will be what friction? Here there will be kinetic friction. So this is the second possibility. Now third possibility is there is slipping here also, here also. In the first possibility, there was no sleeping here, no sleeping here. Both were at rest here also, here also. So the whole system was at rest, right? In this example. In this example, they are moving together means here there is sleeping, but here there is no sleeping. Third example is there is sleeping here also, here also. So that means the two blocks will move with different acceleration. Blocks move with different accelerations. This means there is slipping here also, here also. So both surfaces there will be slipping. Both surfaces there will be slipping. And therefore in both the surfaces there will be kinetic friction. Kinetic friction. Isn't it? So how will we know which case is happening? So we have to do like the previous one. We have to assume one of them and check that assumption. If that assumption is correct, luckily that itself will be the answer. But if that assumption is wrong, you have to go to the next assumption. So that way you have to solve. Now there may be another possibility. How? First possibility said no sleeping here, no sleeping here, right? Both blocks are at rest. Second possibility, the blocks are moving together, means there is sleeping here, but no sleeping here. So there is sleeping here, but there is no sleeping here. Third possibility is there is sleeping here and there is sleeping here. So here also kinetic friction, here also kinetic friction. The fourth possibility is there is sleeping here, but no sleeping here. So fourth possibility is, the fourth possibility is acceleration of 3 kg is 0, meaning this block is at rest, but acceleration of 2 kg is not 0, meaning upper surface there is slipping, lower surface there is no slipping. This is also one possibility. Now how do we solve these kind of problems? Well, you have to check for each possibility. So you have to assume one of the possibility and check. If it is coming correct, if the assumption is correct, then that itself is the answer. You can go to the next question. Otherwise, you have to check all the 4 possibilities. So before that, as you know, to solve problems based on friction, first we should calculate the maximum static friction, right, in each of the 2 surfaces. Before there was only one surface, now we have 2 surfaces, right? So here one pair of surfaces are there, here one pair of surfaces. So here what is the maximum static friction that you calculate? Mu into n. Now here mu is how much? 0.5. And normal force here has to balance the weight of 2 kg, right? So if you consider this 2 kg here, the normal force on 2 kg has to balance the weight of 2 kg, and weight of 2 kg is 20. Why 20? M into G. Mass is 2, G is 10. So normal has to balance 20 newtons. So this will be 20. So how much this comes? 10, right? 5 by 10, this 10 gets cancelled with the 0, 5 2s are 10. Similarly, what is the maximum static friction? Here you calculate mu. What is the mu value here? 0.1 into normal here. Now be careful, normal here is not 3g, because normal here has to balance weight of 2 kg also, isn't it? So if you take these 2 and these 3 as system together, then normal here, let me call it n dash, should balance the weight of both of them, matlab 5 kg, which is the weight is 5g, which is 50 Newton. So normal is 50 Newton, which is equals to here 1 by 10, so this 5 Newton. Now, if you compare the maximum static friction here and maximum static friction here, what do you notice? Here the maximum static friction is less. And remember, who's trying to move this block? Already we discussed before, the friction here. And friction here, maximum value is up to 10 Newton. And here, the friction which is trying to stop this, maximum value is 5 Newton. So clearly, because this is less than this force is more than this. So here slipping will occur first. So try to remember this. Wherever the maximum value of static friction is less, in this example here it is less, that surface will slip first. Okay, if there is slipping, then this will slip first. So wherever the maximum value of static friction is less, there the slipping will start first, if it starts at all. So let us do assumptions and check whether it is true or not. Remember, our aim is to find the acceleration of the blocks. So let us assume first that both blocks are at rest. Both blocks are at rest. Okay, so let us check that whether it is possible or not. So for the first block, 2 kg block, is that possible? You are applying 10 Newton, and to keep this block at rest, at rest means I am saying acceleration is 0. So how much static friction you need to keep this at rest? 10 Newton only. Right? And that 10 Newton, compare it with max static friction. It is exactly equals to max value. Right? 10 Newton here. Isn't it? And can your marks be equal to maximum marks? Yes, it is possible. So this is possible. So it is possible that upper block can be at rest. But don't think our assumption is right, because you have to check for lower block also. I have assumed both the blocks are at rest. So don't only assume for the upper block. Now to check whether there is slipping here or not, you can take either 3 kg as system, or you can take both 2 and 3 kg as system. Let me take 3 kg as system. Now, since I am saying this block is at rest, and to keep this at rest, how much friction should act here? 10 Newton. So reaction of that will act here, 10 Newton. Right? So this is this F. I hope you remember. So right now in this assumption, this friction is 10 Newton. You can see. So this also should be 10 Newton. Right? Action reaction. Okay, these two are action reaction. So to keep this balance, here you need how much friction? Fs dash, let me call. So since this is also not moving, in my first assumption, acceleration is 0. So static friction here should balance 10 Newton. Now checking. So here this was possible. Now here the static friction at the lower surface is 10 Newton. Now check what is the maximum static friction at lower surface, 5 Newton. So this is coming greater than max value. Can your marks be greater than maximum marks? No. So maximum friction here can be up to 5 Newton. But to keep this at rest, we need 10 Newton. So this is not possible. So our assumption is wrong. So acceleration cannot be 0, 0. When it could have been 0? If I had made this friction coefficient here quite high. So if I made it let's say how much? 9. Would it be any chance? 0.9? Let me check. 0.9 if it was, then this maximum value will be 0.9 into 50, 45. And then in that case this 10 Newton is less than maximum static friction if it was 0.9. So then in that case both the block will be at rest, First assumption correct, tick 0 0 and go to the next question. 0 0 means both the acceleration of both the blocks will be 0. But remember, in this question it was 0.1, so this was 0.1, so this was 5, and 10 Newton is not less than maximum static friction. Okay, so here it is not possible because you are asking more than max value. Max value is 5, you are asking 10 Newton here, which is not possible. So here the surfaces will not be at rest. So here sleeping will be there. Now you could have done this part another way. If both of them are at rest, then their acceleration together as a system will be 0. So you could have taken both of them as system together. So that will be 5 kg, right? 2 kg plus 3 kg. And what are the external force? Here it is 5 Newton, here is 10 Newton. Now I will not show these forces, I will not show now, because those are what forces? Internal forces. Internal forces cancels out, right? This F and this F will cancel if you take together as the system. So if you take both as system, then these two are internal forces, they will cancel. So what is the external forces from the ground here? F dash. Now if you assume both are at rest, then acceleration of this whole system will be 0. And to keep the acceleration 0, this F dash should balance 10 Newton. But here friction cannot be 10 Newton because max value is 5 Newton only. So you are asking more than max value, which is not possible. So this way also you can check. Now let us do the second assumption. When both blocks move together, both blocks move together. That means what? That means here there is sleeping, but here there is no sleeping. So here there will be kinetic friction and here there should be static friction. So let us check. Now if both of them move together, then I know they will have common acceleration A. This is the common acceleration, both of them together. So 2 kg and 3 kg I will take as a system because they are moving together, right? Let me call this acceleration AC. That C stands for common acceleration. Now who is giving them external forces? Let us check. So from here there is a 10 Newton applied force, and now we know this there is sleeping here. So this is kinetic friction. And kinetic friction here is same as maximum static friction because mu s and mu k both we have assumed 0.1. So here what is the kinetic friction? 5 Newton. So now apply Newton's law. Total force equals to ma. Total force is 10 minus 5. Mass of the system is 5 into a. So acceleration is 1 meter per second square. Now we need to check our assumption is correct or not, right? If both blocks move together, friction here should be what I told, static friction, because they are moving together, remember, just because of move word, don't think kinetic friction. Here you will say kinetic because here the 3 kg block is moving on the surface. But here you cannot say 2 kg is moving on the surface of 3 kg because the surface of 3 kg is also moving with 2 kg. So both the blocks are moving together. So friction will be static. So we need to check that, right? So now the checking will start. Now to check that, let me take 2 kg as system test. What are the forces on 2 kg? Here 10 Newton. Here friction F. In my assumption it should be static. And don't balance these two because both are moving from ground frame. We apply Newton's law from ground frame, right? So from ground frame you can see both are moving. So acceleration of 2 kg is same as A common. So don't balance, okay? Just because I told the friction is static. Friction is static because there is no relative motion. But from ground frame to you see there is motion, right? There is acceleration actually, I should say, not motion. So net force equals to ma. What is the net force? 10 minus static friction is equals to mass of this system is 2 kg. Acceleration is A common, which is 1. So static friction will come how much? Take this one this side, this one this side. 8 Newton. Now check, is it possible? 8 Newton. Here what is the maximum value? 10 Newton. We want only 8 Newton to keep this and this move together. To move both of them together, remember, we need only 8 Newton of static friction. Here we can get up to 10 Newton. So obviously this is possible because this is less than max value. So this is possible. So since this is possible, it means our assumption is correct, and therefore the answer is acceleration of 2 kg and acceleration of 3 kg both are 1 meter per second square. Friction between 2 kg and 3 kg mass is here is static friction, and the value is 8 Newton. And friction between 3 kg block and the floor, they can ask friction also, is what friction is there? Kinetic friction, 5 Newton. So this is how we can solve this question, right? So let me interchange these values now. Okay, I made this 0.5, this 0.1. So this is 0.1 now, and this will be 2 Newton, isn't it? Yes or no? Okay. And here it is 0.5, and this will come 25 Newton. Correct? Okay. Now, suppose this question was there. First, we will calculate the maximum static friction, and then we will do the first assumption, and the first assumption was both the blocks are at rest. Both blocks at rest. This is my assumption. Now, how to check this assumption? This is correct or not? Well, you can take first both the blocks at system to check whether there is slipping here or not. Because using both the block as system, you can calculate friction here, right? Not here. So let's start with this. So here we are applying 10 Newton like before, and here there is friction static because I am assuming both the blocks are at rest. Now checking. To keep this at rest, static friction should be 10 Newton and maximum value is 25 Newton. So this is less than max value because max value is 25. So this is possible. But that doesn't mean that this is also at rest. This actually means the lower surface is at rest on the floor. That it means. Okay. So here the friction is static. But this doesn't guarantee that this block is also at rest on 3 kg. We have to check for this surface also, and for that we will take 2 kg as system. Here 10 Newton, and here friction is static if I assume both are at rest on the surface, and this static friction should be 10 Newton to keep this at rest with zero acceleration. And here the max value is only 2 Newton. So this is coming greater than max value. How can you become greater than max? So this is not possible. So our this assumption is wrong. Both blocks are not at rest. So now here there is no need to waste our time to check whether they will move together or not. They will never move together because maximum static friction here is up to 2 Newton only. Whereas here maximum static friction is up to 25 Newton. Isn't it? So slipping here will start first. Therefore, this will start moving and this will continue to be at rest. Another way to understand is who was trying to move this body. Think carefully when I discussed this problem at the beginning. Which force was trying to move this body? This friction. Remember, right? When I applied force here, friction here came to oppose that relative motion. And reaction of that friction will act on the lower block. Now this friction is trying to move the body. So for this body, this is like applied force from 2 kg. Think of 2 kg trying to say to 3 kg, come with me like that. Come with me bro, like that. Okay. So this is trying to apply a force of F. Now the max value of that is 2. So on up, this can try to make this move with maximum of only 2 Newton. But here this brother can go up to 25. So this can easily keep this at rest, right? So this will never be able to overcome this because the max value of this is 2. So therefore, there is no point to check whether they will move together or not, because this will never move, remember. Okay. So once we came to know that this 2 kg block will have acceleration, whereas 3 kg block will be at rest. To find the acceleration of 2 kg block, we will use Newton's law. So here is the 2 kg block. Applied force is 10 Newton. Friction here is kinetic now, remember, because this is actually slipping on the surface of 3 kg. So this is kinetic, not static. And there is some acceleration which we need to find. And kinetic friction value is same as maximum static friction in this problem, remember. If they give mu s and mu k separately, then maximum static friction you have to write mu s into n. And kinetic friction you have to write mu k into n. Be careful, okay? But in this question, no need to write mu k into n. It will be same as mu into n, which is 2 Newton. Now write Newton's law. Total force is 10 minus 2, right and left, that is equals to m into a. So this is 8. Mass of the upper block is 2. So acceleration is 4 meter per second square. So what are the answers here? Acceleration of 2 kg is 4, right? Then acceleration of 3 kg is not moving, 0, right? Then friction between 2 kg and 3 kg block here is kinetic, which is 2 Newton, right? This is the answer. And friction between 3 kg and floor is static, which is equals to how much? Here static friction will be exactly that much, which is needed to keep this at rest, right? If you look at the lower block, 3 kg, this friction is acting, this reaction of this friction, and this friction is kinetic 2 Newton, so here also 2 Newton. In this surface there is slipping, no, so friction will be kinetic, remember. But this here there is no slipping, so here friction is static. And how much it needs to be to keep this at 0 acceleration? Exactly equal to 2 Newton. Okay, so this is how we can solve the question. Okay, notice that this friction and this friction are same, obviously, because acceleration of 3 kg is 0. So this friction should be that much, which is needed to keep this 3 kg at rest. And this friction is trying to move it with 2 Newton. So this friction also should be equal to 2 Newton to keep the body at rest. But difference is this is kinetic because here slipping is there. Here it is static because here there is no slipping. Okay, now let us consider a variation of the previous problem where the applied force is not on 2 kg block but it is on 3 kg block. Now, when you apply force here, slipping will never start here first. It will never start here first. Now, why, sir? Why it is like that? That is because in the previous question we applied force here, right? And when you apply force here, there could be slipping in the surfaces either here or here. But it was always below the block where you apply force. So if you apply force here, slipping can start here also, slipping can start here also first. But when you apply force here, slipping will start only in the surfaces below this block where you apply force. And there is only one surface below this block. So slipping will always start here first. But still, why, sir? Why slipping cannot start here? To understand that, think of this. So this is your 3 kg block. First try to draw direction of frictions in different places. So when this block tries to go this way, here there will be friction this way, isn't it? Correct? F dash it was. And this time this block is going this way. So this block will feel friction here, F. And the reaction of that friction will act on 2 kg here. But remember, forces always comes in pair. This reaction of this will act on the table, right? But that I'm not interested because I'm not going to take table as the system, right? Now imagine this is your 3 kg block. and here you are applying 10 Newton. And here the friction will try to oppose this. Let's say the friction here maximum value is 12 Newton or 15 Newton. Then easily it can go up to 10 Newton, right, to keep this block at rest. So how much friction is needed here to keep this 3 kg at rest? This is only able to balance this. So if this is able to balance this, here you don't need any friction. Therefore, if friction here is 0, it means this friction must be static friction, because 0 to friction can provide, right? 0 means nothing is needed. So here this body will not accelerate, because if this friction is 0, this is also 0. So this will not accelerate if this doesn't accelerate, isn't it? So unless this moves, this cannot move. So first movement should happen here only, then only this can also move. Understood? So slipping will always start here first. Before this moves, this cannot move. I hope that is clear here. So now we will do our assumptions one by one and check whether our assumptions are true or not. But before that, we will calculate the max value in each surface. So here what is the max value? Mu is 0.1. Normal force here will balance weight of 2 kg. Weight of 2 kg is 20 Newton. So maximum static friction here is 2 Newton. Here it will be mu is 0.5 into weight will be 50 kg, right? Normal here has to balance the weight of both the blocks. So 25. So let's start checking now. So first assumption, like before, we will assume both blocks are at rest. So for 3 kg and 2 kg, I will take together as system. So here you can see 10 Newton is acting, and to keep the system at rest, I need friction here, which is also 10 Newton. Right? This friction I will not show here, but they are internal forces. Can this be provided by friction here? Yes, because max value is 25. So 10 Newton is less than maximum static friction. So this is possible. So this system can be this surface can be at rest on the floor. Now once we came to know that here the friction is static, means this surface is not moving with respect to floor. Now floor is at rest, so this surface of the 3 kg is also at rest. So this is not sleeping. Once we know this is not sleeping, there is no need to check whether 2 kg will sleep or not. There is no need to check, because I told sleeping will start here first. So if this is not sleeping, this cannot sleep. Mathematically also you can check. Try to draw free body diagram of 2 kg. Now on 2 kg, was there any applied force? This time the applied force is on 3 kg, remember. This is frictional force coming from 3 kg, remember. It's a reaction of this friction. These two are action reaction. But was there any applied force? No. So if there is no applied force, how much friction you need to keep this at rest? 0 friction you need to keep this at rest. Imagine there is a table. I am not pushing it. Just I am looking at the table. Just look at the table. Is there any applied force to move the table? No. So if there is no applied force to move the table, static friction should be 0, because static friction is that much which is required to keep the body at rest with respect to the surface. So if you apply 5 Newton, static friction will be 5 Newton to keep it at rest. If you apply 6 Newton, static friction will be 6 Newton to keep it at rest. If you don't apply any force, static friction will be 0 Newton. Now 0 Newton is obviously less than Fs max. So this is also possible. So both the blocks will be at rest. So the answer of this question is acceleration of 2 kg and 3 kg block both is 0, and friction between 2 and 3 is 0. Friction between 3 and floor is how much was needed to keep the, don't say this, this is the maximum value. So the friction actually acting between 3 kg and floor is 10 Newton, which is needed to keep this at rest. And it is static. Correct? Now let's try to interchange this and see what happens. Okay, interesting, right? So 0.5 and 0.1. So now this is 0.5, so this becomes 10, and this is 0.1, so this becomes 5, and I am applying 10 Newton. So now we'll check if both the blocks are at rest or not. So first assumption, both blocks are at rest with respect to ground, okay, or with respect to this floor. So for that, if I take 2 and 3 kg as system, then applied force is 10 Newton. Here the static friction needed is also 10 Newton to keep the block at rest under this assumption. Can this be provided by maximum static friction here? No, because maximum here can be only 5 Newton. So this is greater than F max. So this assumption is wrong. So both the blocks are not at rest, remember, with respect to the floor, this floor. Now second assumption, both the blocks are moving together. Let's check that one. Both blocks move together. Now if they move together, then they will have a common acceleration. Let's find the common acceleration using Newton's law. This is 2 kg plus 3 kg. Here 10 Newton. And since now this surface is sliding on the floor, friction here will be kinetic. And kinetic friction in this problem is same as maximum static friction, 5 Newton. So if you use Newton's law, total force is 10 minus 5 equal to 5 into A common. So A common is 1 meter per second square. So if both blocks move together, this should be the acceleration. Here remember, sliding is happening. Now we need to check whether here that is possible or not. So this is 2 kg. For 2 kg, if they move together, that also should have same acceleration of 1 meter per second square. And friction here will be static. Why static? Because though it is accelerating, why static? Because they are moving together, I told. And if they move together, then it means you stand here, you will see this is at rest. So relative motion is not there. If relative motion is not there, friction will be always static. So here friction is static. And from Newton's law, this friction should be ma. That's the only force. Mass of this block is 2 kg. Acceleration common is 2 Newton. Now 2 Newton is possible or not possible? Check. Here friction go up to maximum 10 Newton. So it is possible. So this is less than Fs max. So this is possible. Right? And therefore answer will be what for this question? Acceleration of 2 kg and acceleration of 3 kg. Both will be same 1 meter per second square. Friction between 2 and 3 will be static, which is F equal to ma, 2 Newton. Right? This is the static friction, not the max value. Here it is matching with, no, 2 Newton. Maximum value is 10 Newton, so it's not matching. And friction between 3 and floor is here 5 Newton, which is kinetic. Okay. So let us try to make friction here very less. Okay, let us see what happens. So I have taken mu here as 0.05. So what will be Fs max now? Mu into normal here will be 20. That will be 5 by 100 into 20. That is 1 Newton. So now let us take the first assumption. Both the blocks are at rest. both blocks at rest. Will that be true? 2 kg and 3 kg. Applied force here is 10 Newton. Maximum static friction here can go up to 5 Newton. But to keep this at rest, this should balance this, which is coming greater than max value. You can never be greater than max value, so not possible. So 100% here there is slipping. Now once slipping here starts, okay, once slipping here starts, slipping here can also start, right? Only thing is slipping will start first here, remember. So now our second assumption where both the blocks move together. Both blocks move together. Let's check. For together there will be common acceleration. Here 10 Newton. Here kinetic friction 5 Newton. Same thing if you do, acceleration will come 1 meter per second square. Right? 10 minus 5 is the net force. Net force by mass. Mass is 5 kg. 2 plus 3 kg. Now, for 2 kg block, we need to check, right? Because if we assume they are moving together, friction here should be static. Now, who will give acceleration to this 2 kg block? If they are moving together, 2 kg block also should have same acceleration. Obviously, friction from the 3 kg block. From Newton's law, that value will come ma, which is coming 2 into 1, which is 2. And now you can see, 2 Newton, right? Mass into acceleration is force. And this 2 Newton is greater than Fs max. So this is not possible. So now we came to know that this assumption is also wrong. So there is slipping here also, because you cannot have friction more than max value. So let us now try to find the acceleration of each block. But remember, there is no possibility that this is at rest and this will move, because slipping will start first here, I told. Then slipping can start here also. But it is not possible that this one will slip and this one will stay at rest. That is not possible. So for 2 kg block, what is the only force here? Friction, that is kinetic. And kinetic friction here will be maximum value 1 Newton. So acceleration of 2 kg block, Newton's law, force by mass. The only force is 1 Newton divided by mass. I hope you understood how I found this. Friction this time is the force m into a. Friction is kinetic 1, mass is 2. So acceleration is 1 by 2. So now we will take 3 kg as system. Remember, we cannot take both as system now because they are not moving together. They are not moving with same acceleration. So for 3 kg, what are the forces? Here 10 Newton. Here kinetic friction, reaction of this friction 1 Newton. And here kinetic friction, which is max static friction, which is 5 Newton. Remember, both are kinetic. So now net force will be 10 minus 1 minus 5. That is the total force, right? And total force is ma. What is the mass of this block? 3 into a. So this will give you acceleration of the 3 kg block is equals to 10 minus 1, 9, 9 minus 5, 4, 4 by 3 meter per second square. And friction here is kinetic equals to 1 Newton. Friction here is also kinetic, which is 5 Newton. Okay. Now let us do a wonderful problem where there are two blocks A and B, and mass of block A is greater than mass of block B. This information is given, and here the surface between A and B, here that surface has a friction and the coefficient of friction is given as mu. Okay, and here the surface is smooth. So the coefficient of friction will be 0. So here there is no Fs max, and here if you calculate the Fs max, the maximum static friction, here that will be mu into normal here. Normal here has to balance the weight of this block. Weight of this block will be MA into G. That's the first thing we should calculate, right? Now they are asking you to plot graph of acceleration of A and acceleration of B with time. Now why with time? Because here a force is applied which is directly proportional to time. So the applied force will be equal to some constant into time, right? When y is proportional to x, y is equals to constant times x. So that constant I am writing as k. That means the force here keeps increasing with time. Okay. So first of all, understand that here there is no friction, and I told you when you apply force on any block, slipping will start in the surfaces below that block. So if you apply force here, slipping may start in any of the surfaces below. Where it will start first, wherever the max static friction is less. Obviously here there is no friction only. So here the maximum static friction is 0. So here slipping will start first. Now here also slipping may start depending on the value of the force. So first what we will do, we will assume they move together because there is no chance that both the block will be at rest, because here 100% slipping will start. Because once you apply force here, there will be friction, and friction on block A will be this side. Reaction of that friction on block B will be this side, and here there is no friction to cancel this friction. So here there is no need to check that both the blocks are at rest. So let us assume first that both the blocks move together. So both blocks move together. If both the blocks move together, their acceleration will be same. So let me take A and B both as system, and this is the common acceleration for both of them. AC let me write right now, and external forces are here F. These frictions I will not show internal, and there is no kinetic friction here because this is smooth. So Newton's law gives me F is equals to mass into A, force is K into T, and mass of both the block is not same here, is MA and MB. So MA plus MB into A. So acceleration of both the blocks will be KT by MA plus MB. You can see this thing here is constant, so I can write time here. That means acceleration is proportional to time. So the graph of acceleration of both the blocks. Why both the blocks? Because till here we have assumed they move together, right? So this is common acceleration. Common acceleration. So you can see acceleration here is directly proportional to time. And you know from mathematics, when y is proportional to x, the graph is straight line passing through origin. So graph of acceleration versus time will be straight line passing through origin, and the slope is given by this number, right? Slope matlab tan theta, where theta is this angle, right? So the slope tan theta is given by this constant K by MA plus MB. Now will this graph continue like this forever? No, because as time passes by, right, acceleration increases. Now who is giving acceleration to this block? It is this friction, because this is the only force on block B. Applied force is on A, remember. So for B, the acceleration is given by only this friction, and this friction has a max value. So if your acceleration is too high, MA will be very high, MA. And if MA is very high, friction will be also very high to provide that much MA. But friction has a max value, it can't go beyond a certain max value. So there will be a certain maximum acceleration whose time you can easily find by putting a max here. After which these two cannot move together because acceleration required by this cannot be provided by this friction because static friction has a max value. Remember, two things can move together as long as friction between them is static. And the problem is if you apply more and more force, acceleration will be more and more, right? If force is more, a will be more, isn't it? Isn't it? So a will be very high, means this friction should be very high, but unfortunately it cannot go beyond this value. So let us try to find that max value by treating B as system, because in B there is only this force, so it's easier. So on B there is a friction force from A. So from Newton's law, that should be equal to mass of the system into acceleration, right? Okay. And for calculating the maximum acceleration, I should put the maximum value of this friction so that they move together. Okay, this is to move together. How long they will move together? Till the friction is static. But static has a max value. What's the formula for maximum static friction? Here we know mu into mag equal to mb into maximum acceleration, whose maximum acceleration is this b's, remember. So let me write acceleration of b max value. This way is better, no? So this acceleration of b max value for them to move together. So from here the maximum acceleration b can have so that they move together is mu mag by mb. So that is this value. Okay, in graph we can actually write that, no? Mu mag by mb. Okay, after that what will happen after this time, and how to find that time? Just put this formula here, substitute, you will get the t. But they have not asked that t, so I will not be worried about calculating that t. But you can please try. Okay, it is a good question. Now how will the graph look further after this point? What will happen? Slipping will start because you have crossed the acceleration, which is the given by this equation. So friction will be now no longer static, and if friction is not static, slipping will start. That means friction is kinetic. Now once kinetic friction starts, we have to do separately, right? So for block B, let us do first. So this is block B. Here friction is now kinetic. Kinetic friction is mu k into L, but here mu k and mu s we will take both as mu. So Fk here is same as Fs max, which is mu mag. Okay, this formula. And Newton's law, if you apply, kinetic friction is mass of B into acceleration of B. Now you have to separately do, okay, because now it's no longer common. So this will be mu mag equals to mb ab. So acceleration of B will be what now? Mu mag by mb. You can see this is now constant, there is no time. So acceleration of B after this will become constant. Okay, same as this value. See, it matches with this value. This will be constant. But one thing you be careful. First of all, let me mention this is acceleration of B. This graph is for both. Acceleration of A also, acceleration of B also. After this time, okay, slipping starts, I told, right? So, and after slipping starts, friction on B will be kinetic, and from there we have seen the acceleration of B has no time, so it's constant. But one thing, be careful, if they have given here the friction coefficient as mu s and mu k, then here this is Fs max, so this would be mu s, and here kinetic friction, so this would be mu k. So this would be mu k, and you know that mu mu k is slightly less than mu s. So this graph would be AB. This mu k is slightly less than this mu s. This would be mu s, no? So the graph will come down and do like this. So the graph will slightly come down, okay? But here we don't need to worry because the value of mu s and mu k are same. Yeah, fine. Now what about A? Now for A, we need to draw the free body diagram. So A has this applied force and here this kinetic friction, and Newton's law, if you write F minus kinetic friction is mass of A into acceleration of A. Applied force increases with time, right? K into T, it was given directly proportional. Kinetic friction here is same as maximum static friction in this question. So mu MAG equals to MA into acceleration of A. So now the acceleration of A will be K into T minus mu MAG divided by MA. So acceleration of A will be K by MA T minus mu G. Right, I have divided by MA here, MA. So now this would be the equation. This is equation of a straight line like y equal to mx plus c, but here the intercept is minus. So how the graph will be? Now this is also a straight line whose slope is this. This is the slope, right? Y equal to mx plus c. So this is the slope. Before, what was the slope of this straight line, if you remember? When they were moving together, that time we wrote external force on the system is F. Mass of the system is MA plus MB into A. And F was constant into time. So acceleration was KT by MA plus MB. Isn't it? So before the slope was K by MA plus MB, right? In the equation y equal to mx, m is called the slope. So here A is along your y-axis, T is along your x-axis. So this K by MA plus MB is your slope when they were moving together. Now the slope is K by MA. Obviously, this slope is less or more. Remember here plus B. So you are dividing by more. So this slope is less because you have denominator more. Here denominator is less. So this slope is greater than the previous slope. Previous value. Why this slope is again greater? Because you are dividing by only MA. Here it was divided by MA plus MB. So divide by less means you get more. So slope will be more means the graph will go at more angle like this. And if you come back like this, the intercept here will be negative. So this is the right graph. Okay. So in exam you will get some 4 graphs. You have to choose the right one. Isn't it? Let us now start with 3 block system. So I have taken 3 blocks kept on top of each other. 2 kg block, 3 kg block, 5 kg block. And here friction coefficient is 0.4. Here it is 0.1. Here it is 0.2. Again, I have not distinguished between mu s and mu k. So kinetic friction will be same as maximum static friction. Here we have applied a force of 70 Newton and we have to find acceleration of all the blocks. Now, as I told you before, if you apply force here, then surfaces below that block, their slipping will start first. I am not saying friction will not start here or here. It can start here depending on the value of the force. But here it will start first. Therefore, it is not possible that this stays at rest and these guys move. If this stays at rest and these guys move, then it means what? Here slipping started first. But I told slipping will start here first. So therefore, it is not possible that this is at rest and others are moving. Okay. So we'll start with the first assumption. All blocks are at rest. Okay, with respect to ground. So if you stand here, you see all of them at rest. Oh, But before that, we should calculate the max value of friction everywhere, I told. Yes or no? So what is the max friction here? Mu into normal here. Normal here has to balance the weight of 2 kg, which is 20 Newton. So this is 4 by 10, this is 8 Newton, right? 0, 0 cancels, 4 2s are 8. Here what is the maximum static friction? Here mu value is 0.1. Normal here has to balance the weight of 5 kg, so this is 50 Newton, this is 5 Newton. And here the Fs max is, here friction coefficient is 0.2 and normal here has to balance the weight of all of them, which is 10 kg's weight is 100 Newton. This is 2 by 10, 1 0 cancels, 20 Newton. So first we need to check whether all the blocks are at rest or not. Okay. So for that I will draw the free body diagram of the whole system. So the mass of the whole system is 2 kg plus 3 kg plus 5 kg. The frictions here will be internal. I will not draw that. Now when we apply this 70 Newton force, whatever friction here acts is internal, right? So I will not show that. So from the floor there will be a friction, and since I assumed all are at rest, means this is also, so everything is at rest, means acceleration should be 0. So friction here should balance the 70 Newton. But what is the max value of friction here? Max value of friction here is 20 Newton. So 70 Newton is greater than max value. So clearly our assumption is wrong. So clearly here slipping will start. So our this assumption is wrong. So all the blocks are at rest is not correct. Okay. Now let us do the second assumption, where I assume all the blocks move together. All blocks move together. That means I am assuming there will be a common acceleration for all of them. Common acceleration. Mass of this system is 10 kg. Here there is 70 Newton force. Kinetic friction here will be equal to the maximum static friction, right? Already we discussed many times. So what will be the acceleration of this whole system if they are moving together? The Newton's law will give total force is 70 minus 20. Mass of the system is 10 into A common. So A common will be 5, right? 50 by 10. Now we have to check, right, whether they are moving together or not. This is just assumption. Now to check they are moving together or not, we should check whether here friction is static or not, whether here friction is static or not, right? So we have to check one by one. So now let us try to draw the direction of friction. So when 70 Newton will try to go this way, friction here will be this side, I told. And if this friction is able to stop this block, then friction everywhere will be 0. We discussed already. But here friction is not able to stop this block. We have seen already. So there is sliding here. So friction here is this way. Already we came to know kinetic friction. Now if you want to know the direction of friction here, when 5 kg will try to go this way, 5 kg will feel friction force this side. Reaction of that will act on 3 kg this side, obviously. When this block moves this way, this block will say to 3 kg, you also come with me. So force on 3 kg by 5 kg should be this way. That force will try to move 3 kg this way. So friction on 3 kg will be this side. This is due to whom? This is due to the 2 kg block, right? And reaction of that will act on 2 kg block this way. So these are the arrows showing the friction. Okay, I'm not writing F there because already I have written many things, right? So try to understand these arrows represent friction on the blocks by the other block in contact. Okay, so now we have to check whether this acceleration can be given by static friction or not. So for 2 kg block, in order to go with this acceleration, it needs a force, Newton second law. What is the force on 2 kg block? The only force on 2 kg block is this friction force. And that friction force will be m into a, Newton second law, that is 10 Newton. Now check. Here what is the maximum static friction? 8 Newton. Here you need 10 Newton. That means this is greater than Fs max. You can never be greater than maximum value. So this is not possible. So our assumption that all the blocks move together, that is not correct. So now we came to know that they are not moving together. All the three are not moving together. But still there is a chance that 2 and 3 are moving together and 5 is moving with some different acceleration. Meaning here friction is static but here friction is kinetic. That is possible. Or 3 and 5 are moving together and 2 is moving with another acceleration. Meaning here the friction is static but here the friction is kinetic. Or it is possible all are moving with different acceleration. So here also kinetic, here also kinetic. Here the already we know is kinetic. So we have to check for all, right? Now let us check next assumption. We will assume 2 kg plus 3 kg are moving together. Okay, only these two are moving together, but here there is slipping. So here the friction will be kinetic, here the friction will be static. So if I assume 2 and 3 kg are moving together, then you may be thinking, let us take 2 kg and 3 kg as system together. Not a bad thinking. I am also thinking same way. So let's see. Now, what are the external force pulling these 2 and 3 kg? Well, these frictions are internal that I will not show. Here there is friction, right? This side. Now, because I am assuming 2 and 3 are moving together, not they are only moving together, but between 3 and 5 there is slipping. So if there is slipping here and here there is no slipping, then this friction will be kinetic. And that kinetic friction has a max value which is same as the maximum static friction, 5 Newton. Correct? Okay. So now what will be the acceleration of this common acceleration for these two to move together? So friction is equals to mass into acceleration. This is the only force I can see on this system. 5 equal to 5 into A common. So A common equals to 1 meter per second square. Now we need to check this assumption is correct or not. To check this assumption, we have to see here friction is static or not. So let me take 2 kg block. This is the surface of 3 kg. Okay. Now here there is friction, this red color friction, Fs. And if this is moving together with 3 kg, then they should have this much acceleration. 1. From Newton's second law, there is 2 into mass into acceleration, 2 Newton. Here maximum static friction can go up to 8 Newton. So this is less than 8 Newton, or I should say less than maximum static friction at this surface. And this is possible. Right? That means 2 kg and 3 kg are moving together. So acceleration of 2 kg and 3 kg both are 1 meter per second square. What about acceleration of 5 kg? For that we need to apply Newton's second law for 5 kg. So if you look at 5 kg, here there is applied force of 70 Newton. Here there is kinetic friction, which should be the maximum static friction, 20. And here I am saying there is slipping, so there will be kinetic friction that is equals to maximum static friction here 5. So net force will be 70 minus 20 minus 5. That should be mass into acceleration of 5 kg. So acceleration of 5 kg block will be 70 minus 20 50. 50 minus 5 45 by 5. So 9 meter per second square. So acceleration of 5 kg block is 9 meter per second square. So that would be the answer, isn't it? If they ask friction here, that is static friction, 2 Newton. If they ask friction here, that is kinetic friction, 5 Newton. If they ask friction here, that is kinetic friction, 20 Newton. So friction also we can give at different surfaces, right? Now out of curiosity, I want to check what if these two are moving together. Here though it is not possible, but in some other problem. So let's check that one. So 3 kg plus 5 kg move together. That is my assumption. Now if I say 3 kg and 5 kg are moving together, then this will be my system. 3 plus 5. Here 70 Newton is acting. Here kinetic friction, because I already told there is slipping here, so 20 Newton. This is 70 Newton. Kinetic friction, remember. And because I am saying these two are moving together and here there is slipping, there will be kinetic friction, and that kinetic friction is the maximum static friction here, which is 8. Remember, this 5 Newton here, that is internal forces, okay, no need to include. So total force will be what? 70 minus 20 minus 8, that will be mass of the system is 8 into A common. A common for whom? 3 kg and 5 kg. That will give you 70 minus 20 50, 50 minus 8 42 by 8. This will be 2 2s are 4, 2 1s are 2, 2 4s are 8. So 21 by 4 meter per second square. So now here we assume 3 kg and 5 kg are moving together. So there is slipping here, but these two are moving together. So this friction should be static. So to find this friction, I can either choose 3 kg as system or 5 kg. I will choose 5 kg. You can take 3 kg also, because you know this friction is kinetic, whose value is 8 Newton. But let me take 5 kg. So here 70 Newton already is the applied force. Here kinetic friction is 20 Newton. And here this friction we don't know. It is the static friction. Now it could be this way also. Okay, that because static friction will be always that much which is needed to keep the body at rest. So let us try to see. So if positive sign comes, then our direction is correct. If negative sign comes for static friction, then it means the static friction should be this side. Anyways, and if they are moving together, then 5 kg also should move with what acceleration? 21 by 4, same as the one we calculated here. Now write Newton's law. 70 minus 20 minus the static friction equals to mass of the system is m into A. Correct? Let's simplify. This is 50. This you take here, this you bring here. So this is minus 5 1s are 5, 5 2s are 10, 105 by 5 equal to Fs. So static friction here comes out to be, this is 4, sorry. So how much it will come? 50 minus 105 by 4 will be how much? 4 2s are 8, right? 2 kg. 4 6 are 24, 1 kg. 4 2s are 8, 4 5s are 20. 6.2, 26.25. Now this number will be obviously much more than Fs max. Fs max at this surface is how much? 5 Newton. So clearly this difference will be more than 20, 100%. So that is much more than the maximum. So this is not possible, right? This is not possible. Therefore, our assumption is wrong. So that is how we have to do 3-block system. So let's see the next question now. So I have again taken 3 blocks, 2 kg, 4 kg, 3 kg, and now I have applied a force of 24 Newton on the middle block. Friction coefficients are given. We have to find acceleration of each block. Now here, if you remember, I told since force is applied here, slipping will never start here first. Slipping may start there, but it will not start first. Slipping will start either first here or it may start here first. One of them. Where it will start first? Wherever the maximum static friction is less. So let's calculate that. So here the maximum static friction will be 0.2 into normal force here has to balance the weight of 2 kg, so 20, so 4 Newton. Maximum static friction here is how much? Mu here is 0.1 into 4 plus 2, 6 kg into g will be 60, so this is 6 Newton. And maximum static friction here is equals to mu is 0.2 into the weight of this, everything here is 3 plus 4, 7, 7 plus 2, 9, so 90 which is equals to 18 Newton. So from this calculation we understood that maximum static friction here is less than here. So slipping will start here first. Okay, if this force increases from 0 to 24, I know we have applied a constant force, but even that must have increased very quickly from 0 to 24, right? Before, so no force was applied, now 24 Newton is applied. So it must have increased very quickly from 0 to 24. During that increase, if slipping starts, it will start here first. That you remember. So since slipping starts here first, it is possible that only these two may move together and this may be at rest. It is possible, okay? You can also notice that this block cannot move in this problem, this block. Why? Because as this block moves this side, this will try to tell this one, you also come with me, right? Like I gave you example before. So when 4 kg will go this way, friction on 4 kg will be this side. Reaction of that on 3 kg will be this side. Now that friction is trying to move the 3 kg block, but that friction has max value 6 Newton. Whereas here the static friction which will oppose that force is up to 18 Newton. So this will say your maximum is very less compared to me. Therefore, I can easily balance you. So 3 kg block will never have any acceleration. But still we will check all the assumptions for just clarity of how to apply Newton's law in different problems. Okay. So let us start. So our assumption will be first, let us assume all blocks are at rest. All blocks are at rest. So if you assume that, then the total force on this system is 24 Newton. And that 24 Newton has to be balanced by static friction here. Now I am doing it little fast. Okay, I am not drawing diagrams because already we have learned so many times we have done, right? So if I take whole thing as system and if everyone is at rest, acceleration of this system will be 0. So net force should be 0. So here 24 Newton, so friction from the floor. Other places the friction cannot come, those will be internal forces. So friction from the ground has to be 24. Now max here is 18. So you are greater than max. So 100% our assumption here is wrong. Now the next assumption that we have been doing till now is assuming all the blocks to move together. Well, that assumption no need to check here because that is not possible, because already I told friction here maximum value is less. So here slipping will start first. If you say all the blocks are moving together, then it means here there is no slipping started, but here slipping has started. That is not possible. but you can still check. So let us quickly check once. Okay, let us assume all of them are moving together. Fast. Then here 24 Newton, and if it is moving, here kinetic friction will be there, which is same as maximum static friction. The mass of the system is 9 kg, right? 3 plus 4 plus 2. So the acceleration common will be equals to total force by mass. Total force is 24 minus 18. Mass is 9 into A. Newton's law, total force equals to ma. So acceleration will be 24 minus 18 will be 6 by 9. 3 2s are 3 3s. So this would be the acceleration. So now for all of them to be moving together, here friction will be static, here friction will be static, right? Now when 4 kg will go this side, friction on 4 kg will be here, and that reaction will be here, right? 4 kg, this 4 kg will tell 2 kg, you also come with me. And when this will go this side, here friction will be this way, reaction of that friction will be here this way, and to oppose that friction here will be this way. So these are the arrows representing friction. Now if you look at 2 kg block, the friction F, this friction has to provide the common acceleration ma. M for this is 2, acceleration 2 by 3, so 4 by 3, which will come 1.33. Now you may say, wow, this is less than max static friction. So you may say this is possible, and then you may say that is the answer, sir. All of them are moving with this acceleration because it is possible. But you have to check for this also, right? Only for that you cannot check. So to check for this surface, what I will do? So now I have to check for this surface also, right? So to check for this surface, I will take 2 kg and 4 kg as system. So here applied force on 4 kg is 24, and I am seeing all of them are moving with common acceleration 2 by 3, and here static friction is, let's say, Fs. That's the only force on this system, right? This 2 will be internal between 2 and 4. So this is the external force from 3 kg. And since I am saying they are moving together, friction will be static. So now check 24 minus static friction. Its mass is 6 into common acceleration is 2 by 3. 3 2s are 6, so 24 minus static friction is 4. So static friction will come 20, isn't it? This will go here, this will come. What is the maximum static friction here? 6. So this is coming greater than maximum. So that means this assumption is wrong. All the blocks are not moving together. Okay. So now we will take 2 kg and 4 kg as one system. 2 kg and 4 kg move together. This seems reasonable because I see that here sleeping starts first anyways, so maybe 2 kg and 4 kg move together. Let us check. So now if you look at 2 kg and 4 kg together, so the 6 kg, here 24 Newton force is there. If they move together, friction here will be kinetic, which is here maximum static friction, right, which is 6 Newton, and this is going with some common acceleration, right? AC, the Newton's law you write, 24 minus 6 net force equals to m into A common. So this gives 18 equal to 6 into AC, so AC comes 3 meter per second square. Okay, so that would be the acceleration of the 2 kg and 4 kg block if they move together. But is it correct? For that we need to check for 2 kg free body diagram. So for 2 kg, this is the only friction force, that should be MA. M is 2, A is 3, this is coming 6 Newton. But here, oh, this is maximum static friction is 4, sorry. So this is also not possible. Okay, Now, what is the next assumption you can do? You can assume 4 and 3 are moving together, but that would mean that you are assuming here sleeping starts first. That would be wrong. So you can check that part, you will get wrong answer. So therefore, no need to check these two will move together. So the last assumption is all move with different acceleration. All move with different acceleration. So for 2 kg, what are the forces? Here on 2 kg there is this friction. It is kinetic. That is equals to how much? 4 Newton. So acceleration of 2 kg will be what? Force by mass. Force is 4 Newton, mass is 2 Newton. So 2 meter per second square. And friction here is 4 Newton kinetic. So one answer already found. Now for 4 kg block you see. Here friction is kinetic, which is reaction of this 4 Newton. And here friction is also kinetic. This is also kinetic here, right? You can see that kinetic friction here, this one is 6 Newton. This is also kinetic. Here applied force is 24 Newton. So acceleration would be, force is how much? 24 minus 4 minus 6 divided by mass is 4. So this is 20. 20 minus 6 will be 14 by 4. 7 by 2 meter per second square. Okay. And this block will be at rest only. So 3 kg block will be at rest. Why? Because the force which is trying to move the 3 kg block has maximum value 6 Newton. Whereas this maximum friction can go up to 18 Newton. So 3 kg block will be at rest. So acceleration will be 0. Right? If you draw the diagram, here friction is how much? Kinetic friction. So this is 6 Newton. And here the friction that is necessary will be, this is, remember, the friction here can go up to 18, but here is 6 Newton, right? So how much you need to keep this at rest? 6 Newton. So friction at the lowermost surface will be 6 Newton, which is static. So here static, here kinetic, here kinetic. And acceleration of 3 kg block is 0 because this force which is trying to move the block is lesser than the maximum static friction. Okay. So this question is taken from H.C. Verma sir's textbook, and it says there are 3 blocks, 2 kg, 3 kg, 7 kg, kept on top of each other in this way, and this surface is fixed. Here there is friction and the coefficient of friction is 0.2, here is 0.3, and this is this is 0. That means this surface is smooth. So this is smooth, okay, and he is applying 10 Newton force on each block one by one, and we have to find acceleration of all the 3 blocks in the 3 cases. So let us apply the 10 Newton force on the uppermost block, and we will calculate acceleration of the 3 blocks. Now here the first assumption that all the 3 blocks are at rest, that will not happen because this surface is smooth. So clearly slipping will happen at this surface. Okay. So there is no friction here to balance this force for the whole system. So no need to check the first assumption. Let us check if all of them will move together or not. Okay. So first assumption, all blocks move together. So if you do that, then for this whole system, the common acceleration will be, external force on this whole system is 10 Newton divided by mass of this system is 7 plus 3, 10, 10 plus 2, 12. So this will be 5 by 6 meter per second square. Now is that assumption correct? We have to check. For that, friction at each surface should be static. So let's calculate. But before that, let's draw the direction. So when you move 10 Newton this side, sorry, when you move 2 kg block this side, with the help of this 10 Newton force, there will be friction this way, reaction of that will be here, right? This 2 kg will say 3 kg, I am going there, you also come there only. Then as 3 kg goes there, friction on 3 kg will be here from 7 kg, and 7 kg will feel reaction this side, and here there is no friction to stop 7 kg, right? So 7 kg will 100% have acceleration in this case. So there is no need to assume this is at rest or all the blocks are at rest. So that assumption is of no use. Now, if I say all the blocks move together, then acceleration will come 5 by 6. For that, I have to check here friction is static or not. So let us take this 2 kg block. Here 10 Newton force is acting. Here static friction, we don't know. Acceleration should be 5 by 6 for all of them. So write Newton's law. Total force this side is 10 minus friction. Mass of the system is 2 into acceleration is 5 by 6. So that will be 10 by 6. So if you rearrange, static friction will come 10 minus 10 by 6. That will be 60 minus 10, 50 by 6, right? And that much Newton. Or I can still further divide by 2, 25 by 3 Newton. So this will be 8.333, right? 3 8s are 24, 1 K. And whatever this comes, 8 point, that is more than or less than the maximum static friction. So that is the first thing we have to do actually, right? But so many times we did these problems that let us calculate. So maximum static friction here will be how much? 0.2 into 20, that will be 4 Newton, correct? Maximum static friction here, it will be how much? 0.3 into 3 plus 2, because friction normal force here has to balance 5 kg, so 50. So 0.3 into normal here will be 50. So it is 15 Newton. Correct? No. So the friction that came here, which is here, this friction is 25 by 3, 8 point something, but maximum here is 4 Newton. So this is coming greater than max value. How can you be more than max? Right? So this is wrong assumption. So our blocks are not moving together. Right? So now we came to know all the blocks are not at rest. All the blocks are not moving together. Now, other possibilities are what? These two are moving together or these two are moving together. Which one to check earlier? Better to check these two are moving together, because we know friction maximum here is less than here. So even if slipping starts, it will start here first, not here. So therefore chances of these two moving together is more. So start with that assumption, you will get answer faster. So next assumption I will do 3 kg plus 7 kg move together. Again this assumption you have to check, but okay. So the system will be now 3 and 7 kg, which will be 10 kg. What are the external forces? This 10 Newton is not acting on 3 or 7, remember. And here there is smooth. So this friction on 3 kg by 2 kg. That is the only external. And that must be kinetic, because we are assuming these two are moving together. Together, matlab these two are moving together but with different acceleration from 2 kg. So 2 kg will have some acceleration, these two will have same but different than 2 kg. So they will be slipping between 2 kg and 3 kg. And if slipping is happening, then friction will be kinetic. So kinetic friction is equals to how much? Here it's same as maximum static friction, 4 Newton. So 4 should be equal to mass is 10 into A common. So A common will be 0.4 meter per second square. but we need to check whether this is possible or not. So to check, choose 7 kg as your system, easier one. Here there is no friction, here there is this friction, and since I'm saying they move together, friction here should be static. M into A, 7 into common acceleration is 0.4. This is 2.8, right? 7 fours are 28, which is 100% less than maximum static friction. So this is possible, right? So we came to know these two are moving together. So answer will be what? Acceleration of 3 kg and 7 kg is 0.4. Okay. What about 2 kg now? Now for 2 kg, draw the forces. Here 10 Newton. Here kinetic friction, which is maximum static friction. So acceleration of 2 kg will be, total force is 10 minus 4 divided by mass is 2. 6 by 2 will be 3 meter per second square. So acceleration of 2 kg, 3 meter per second square. 3 and 7 will move together with this acceleration. Friction between 2 and 3 is how much? Friction between 2 and 3. This is the friction which is kinetic, right? So 2 and 3. The friction between 2 and 3 is kinetic, which is equals to 4 Newton. Friction between 3 kg and 7 kg, they are moving together, so it is static friction. And that static friction between 3 kg and 7 kg is 2.8, right? This is the static friction. And here there is no friction, right? Now, if you assume 2 kg and 3 kg move together, that would be wrong assumption, because that would mean that slipping here started before here. That is not possible, because here friction is less. So that assumption you should not take. Now in the second case, they have applied 10 Newton force on the 3 kg block. As we know, all the blocks will not be at rest because this surface is smooth, right? So we will assume all blocks move together first. And what will be common acceleration? External force on the system is 10. Mass of the system is 7 plus 3. 10 plus 2, 12. So this will be 5 by 6 meters per second square. Now who will provide this acceleration to this 2 kg block? This 10 Newton is not acting on 2 kg block, right? So the friction only has to be provided. So that will be, mass is 2, acceleration is 5 by 6, 10 by 6, isn't it? Which is 5 by 3, 1 point something, which is less than 4 Newton maximum static friction. So this is possible. So here it is possible that these two move together. Let us check here also, 3 and 7. So for that I will take 7 kg as system. Who will provide 7 kg this acceleration? Of course friction from 3 kg, because this is smooth. So here the friction will be, mass is 7, acceleration is 5 by 6. So this friction will come 35 by 6. So that will be 5 point something, which is again less than maximum static friction. So this is also possible. So here also static friction, here also static friction. That means these two surfaces are not slipping. Not slipping means they are moving together. And acceleration for all of them will be this. So this would be the answer. Okay. And friction here will be static, friction here will be static, friction here will be 0 because there is no friction only. In the third case, they have applied force here 10 Newton. So again you can start with assuming all of them move together. Common acceleration will be 10 by 12, 5 by 6. Now let us check. When you move this one this side, 7 kg will feel friction this way, right? From 3 kg, reaction will act here. That's why 7 kg will say 3 kg, you also come with me. When 3 kg will go this side with respect to 2 kg, 2 kg will apply a frictional force in opposite direction, and therefore reaction will act in this direction. So those are the frictional forces. Now for 2 kg, if they are moving together, somebody has to provide this. So that will come from friction only, this friction. Static we are assuming, which is 2 into 5 by 6, 2 by 3. Already I told this is possible, right? So this is possible. Now to check the friction here, so better to take 7 kg as system. Then here 10 Newton, and friction here would be this side. Here there is no friction, so Newton's law will give you total force will be 10 minus friction equals to mass into acceleration. If you assume common acceleration, then 5 by 6, right? So static friction will be, take this one here, bring this one here, so 10 minus 35 by 6, which is 60 minus 35 by 6, which is 5 here, then 25 by 6. This will be 4 point something, which is again less than maximum static friction. So this is also possible. So even in this case, all will move together with same acceleration, right? Now let us discuss this last question. So I have 3 blocks, 1 kg, 3 kg, 2 kg, and here one force is applied, which is unknown. Here there is friction, coefficient is 0.5, here the coefficient of friction is 0.5, and this is 0 coefficient of friction because it is given smooth. We have to find the maximum value of F so that no slipping occurs between any two surfaces. So more than that force if you apply, then slipping will occur. Now of course here the slipping will occur, so between any two surfaces means between 1 kg and 3 kg and 3 kg and 2 kg. So what is the maximum value of this F so that no slipping occurs? More than that force, slipping will start. Now here obviously slipping will start because this is smooth. So for that what we will do, for this, to answer this question, first we will calculate the maximum value of static friction. So here what is the maximum value of static friction? Mu is 0.5. Normal force here N should balance the weight of 1 kg, which is mg, right, 1 into g, that is 10 Newton. So that is the weight of 1 kg, m into g. So 10, that will be 5 Newton. So maximum static friction here is 5 Newton. Here what is the maximum static friction? Here the friction coefficient is 0.5 and normal here has to balance the weight of 4 kg means 40 Newton. This is 20, isn't it? Now please understand that there is no friction here. So no friction here will be able to balance this force. Understood? So the whole system will obviously have acceleration towards right side. So let us assume all of them are moving together once and see what is the common acceleration. Force divided by mass, isn't it? External force on this system. There is no friction here. So external force on this system is F. And mass of this system is 3 plus 2, 5 plus 1, 6. So this is the equation between the external force and the common acceleration if they move together. Remember that slipping should not occur. That means they should move together. Now, where will slipping start first? Here or here? Here though already it has started. Here and here where slipping will start first as you increase the force. Well, you can see here the maximum static friction is less. And I have told many times, wherever maximum static friction is less, their slipping start first. So we have to consider this surface. Okay, because here chances of sleeping is more here, so this less compared to there, so here they will move together only. Here we are worried, so we have to check here. So now when sleeping is about to start, not still started, okay, it has not started, about to start, is about to start between 1 kg and 3 kg, the friction between them, which is F1, will reach its max value, correct? And that max value is given how much? 5 Newton, isn't it? Now let us try to understand, if all of them are moving together with this acceleration, then for 1 kg, let us try to apply Newton's second law. So here this applied force which we don't know, and here this frictional force F1, and it is going with common acceleration AC, which is F by 6. So apply Newton's law to this 1 kg block. F minus friction is equals to M, which is mass of the first block is 1, into A, which is A common, right? Now this is F1 and A common is what? F by 6. So I bring it this side and F1 you take that side, you will get F minus F by 6 equals to F1, right? And that will give you 5 F by 6 equals to F1. And if you want the max value of the force at which the sleeping is about to start, F1 will reach its max value. F1 will also reach its max value when sleeping is about to start. And F1 max we know is 5. So 5 cancel, cross multiply. F max will be 6 Newton. So always check where sleeping will start first, and there you try to put the condition of sleeping. And the condition of sleeping is when the sleeping is about to start. Okay, not yet started, they are moving together only. So they are moving with common acceleration. But at that point when sleeping is about to start, friction will reach max value. Okay.